The other thing I wonder about safety, is it okay if I grab for anyone? And then look at that. Look at that. Back drivable. So if this, for some reason, it loses power and falls down on me, I can just move it out of the way. And I'd literally like to do like a head to toe. And probably where I'll start at is actually the waist. Because the first thing we talked about is that I knew you were getting the movements in the waist, but you were using a linear actuator for that. And I felt like, oh, that linear actuator is taking up some space claim in the torso that you'd like to put batteries and electronics in. And you said, don't worry about that. But I had to keep my mouth shut. Yes. And now we've seen that you changed that. And not only that, the last version had lots and lots of linear actuators. Yes. And now you only have them in a couple of key places where it really makes total sense to have them there. And you've gone full rotary. Yes. Explain that to me.
Yes.
You know, the same kind of strategy down there at the ankles that we have up here, except in that case, they're parallel because you have no problems with the packaging. So from the standpoint of the kinematics, there's been some nice changes, but there's some other aspects to it that are non-kinematic that you probably like to talk about. And I think it's like this area right in here.
This area. So what we have here is side one, it's like the skin. So this is what we're showing there also. Yes, easier to show because normally they just get signals or not.
Yeah.
So here basically it's also when you touch it, it knows how hard you touch. It's actually just inside a paint.
So David, welcome back to the Self Robotics Podcast. So it's nice to actually be able to interview you in person, and congratulations on the launch of For Anyone Generation 3. And if you remember when we first spoke, I think it was like maybe almost 2 months ago, to my shock and surprise, you and your team had actually seen my breakdown video of the second generation bot, and you actually liked it.
Yes.
I was a little bit afraid. And you had told me that there had been some changes that were made. I don't think under my prompting, but you were moving in a particular direction. And it's definitely different. There's a lot of changes that are going on here. And I'd literally like to do like a head to toe. And probably where I'll start at is actually the waist. Because the first thing we talked about is that I knew you were getting the movements in the waist, but you were using a linear actuator for that. And I felt like, oh, that linear actuator is taking up some space claim in the torso that you'd like to put batteries and electronics in. And you said, don't worry about that. But I had to keep my mouth shut. Yes. And now we've seen that you changed that. And not only that, the last version had lots and lots of linear actuators. Yes. And now you only have them in a couple of key places where it really makes total sense to have them there. And you've gone full rotary. Yes. Explain that to me.
Yes. Like, so what we have here, like for as natural walking as possible in the same level also interactive environment, and having a little bit more, let's say, even degrees of as a human is sometimes stands for. And for that, we actually changed the concept.
Yeah.
I'm not saying that I'm 100% now convinced that this is the, let's say, version forever, because in the part of the upper body, we have now, let's say, much more degrees. So it could actually turn the whole, let's say, upper body into the backside, and as we saw in the Boston analysis.
Right.
It's pretty much the same way now.
Okay.
And normally there's a light, so this is why I'm fortunate. Like, I don't know what happened, but there's some light and you see a little bit through. So then you see.
Oh, you can see what's in there. Because I was assuming, so it's covered up, and the assumption is that you have a full 3-degree of freedom waist. So you can do the rotation this way. And you can also go back and forth this way. Now, the way you do the last 2 degrees of freedom is that you have some kind of like universal joint there and actuators. And you used to have the linear actuator, which was pushing it back and forth. Now you've done what I call a kidney style waist. You've got 2 rotary actuators at the kidneys that are able to parallel move it this way or move it that way. Interesting question about that is that a lot of the design spaces in the humanoid bots are converging in certain areas. The waist, no one has decided what's the best one. There's 0 DOF, 1 DOF, 2 DOF, 3 DOF. and even a 4-DOF. In the 3-DOF space, they seem to be kind of similar to that idea. That's the best way. But the question is, why a 3-DOF waist? Why not a 2-DOF?
Yeah, it's actually for us right now. It's mainly because of the like the policy of standing up again.
Okay.
We got a little bit of, let's say, with the linear axis, we were too limited actually to get enough, let's say, movement into the upper body to stand up very natural.
Oh,
that's the main reason.
I would have thought there'd be other reasons, but that's an interesting answer. Now, if we move up, because we've got 3-DOF down there, I believe you have 3-DOF in the neck as well, correct?
Yeah.
All right, so that means you could.
We have actually this mechanism is in the head.
Is basically in the head. So the first one is you've got probably a rotary that allows you to go back and forth this way.
It's this axis here.
And
so we actually use exactly this component which you can detach.
Okay.
It's a detachable lower arm. Let's say this piece we can detach and can put other things in. We have other version also of it, because you don't always need, sometimes you need maybe just something which is just rotating endless and
right.
So it's a lot of things where you have to think different.
Okay, so you can replace it.
But this part is also the same part which is here inside.
Okay, so reuse.
Yeah, we turn and we have, let's say, orientations.
Yes.
Also, that's actually.
Now so it's a similar problem. So you've got the same kind of component there. I wasn't sure. It looked like it was almost the same, but I thought you may have scaled it a little bit different. But again, it comes down to the question. I understand why you need 3 degrees of freedom in the wrist. Why do you need it in the head? Now, I know you come from Germany, you play football here, and that's a very important sport. And of course, we know Klose scored most of his goals with a header, and you need that degree of freedom, right? So from the standpoint of a humanoid bot, why do I need to do that? Why can't just hand and tilt be good enough?
Yeah, it's actually at this time, I would say we're just leveraging this a big bot. In the other is like, for us, it's just important that we have all the degrees of freedom, because tilting the cameras in the right direction, getting the better view, because as more degrees of freedom you have, as better is it.
Right.
It means that's actually the whole point about the cameras, for example.
Yeah.
If you have cameras, you mostly face the issue of bad light conditions of whatever, because this is always the complaint we get. So that's also why it's good to have them in most movable parts, so you actually can simply tilt the head a little and just see better.
And just get it better.
That's basically where it comes from. And the other part is like you could also turn it completely. It looks freaky, but it's actually the same, let's say, as with the upper body, like we can just
as much. Yeah. So there is no mechanical limitation. It's just a question of whether we're going to limit software of not being able to go too far.
This time we're limiting it, actually. Does not make sense right now. I think in the yes, as more stability these products get, as more you get as a gadgets inside, then it's all about you're working on one working space. You work here, you turn the whole upper body, work there, and then or you turn inside and work on both sides, because the robots are smart and you can do a lot of things parallel.
Yes. So I agree. You need probably the most important degree of freedom in the waist is at least being able to do that. So if you're going to pick just one, you only have one, you would have that. The other two are very good for stability, being able to get into the tight spaces. Your wrist is really cool, because the more I look at it, the more it's sort of changed, or maybe there are things I didn't notice before that I want to point out. And that is, of course, if I put my hand right next to here, so if I'm straight like this, that I can move my arm a lot this way, my wrist this way, but not so much that way. I have a limited degree of freedom. And we can see the way it's cut out here is for anyone, it's the same thing. You've got a lot of range of motion this way, but not as much that way. And that was intentional. And but you had to design the mechanism just right to do it. So you have the same degrees of freedom. And of course, you're a little bit limited that way, which is all right. Turns out you have the same limitation in the head. I can move it way down that way, but not so much up that way, which is why it makes sense to repurpose it up there. Yeah. And the other thing that people may have seen that wrist mechanism before, but it's a little bit different, because I've seen these two linkage mechanisms come down, and usually the attachment points are parallel to each other. Notice in your case, you rotated them in. And I assume part of that is for packaging. Packaging. It fits in there better. If you keep it parallel like that, it's going to stick out a bit more. So it was
why the cutout here is like only in the one direction, or like you're simply going inside, and it's And pretty much just what we have.
Right. If you look at everyone else's solution for that, it seems to be really bulky and gets in the way with a lot of snag points in there. So I do like the packaging that you've been able to do there. The other thing that's really quite interesting is the hip is very different. So the last one, there was a lot of linear actuators in there. And now it's very different. It's more compact. And
but because we have like a complete new gearbox, like complete new actuator method. So before we had the issue to get the power here. So we have 380 newton meters, for example. To get them inside, you had we're way too late. So the power density was simply not good enough. And with this one, we simply changed it, or we simply said, okay, we have developed new gearbox technology, and we can now do it. And still, fast enough and strong enough, and this is also why we changed it back, because we get just, in this case, again, more degrees of freedom, and you have something which is faster and easier to reproduce.
Yeah.
And also to work on.
Yeah. Now, so this is what I call the far hip design. So we have the flexion coming through here, and then abduction, which is actually occurring at this point, even though the actuator is down here.
Yeah.
So there's a remote actuation strategy. And this is clever because everyone else is trying to put the actuator right there. And when you put it right there, well, they don't put it right there. They put it back there. And that way you get this big butt that's coming out. So what you've done is you said, wait a minute, let's package it in the upper part of the leg where we have a lot of space. And then your rotation happens down there. So you move that down a little bit. And that allows you to have a very compact, very sleek looking hip. And then that is cool. That's kind of a novel approach. Again, using a little bit of remote actuation.
I will later show you again how it's exactly shaped, like you naked.
Yeah.
So, but it's exactly like that. So you have also kind of a limitation because it's mainly control limited. Because let's say you come up to 30 degrees, and then you actually have to control it the opposite way because you're going in the other direction.
Oh, okay. So
this is basically where it comes from, but the most things you don't need more than this. So and this is actually also where, but you stand up, for example, you would need.
Right.
So you could actually turn the whole leg, if possible, but at the same time, let's say you don't need it all the time.
Right.
So that's how we got also the max out, and you get a lever arm to get.
It's true, exactly. So you don't need to do the splits. That's really rare. For most operations, you're going to be about like that just for balance, and there's no reason to go beyond it except you need to do gymnastics. And the thing I joked is, okay, yeah, it's possible.
And it's just a way of how we do it. So
Right.
and this is the big difference. But it's possible. You can also lift the leg completely up.
All right.
And it's just like when you're going up to 30 degrees about this a little knot. We're getting to a point where you have a little.
It's not quite a singularity, but it's kind of passing through a deadlock. Yeah, exactly.
It's you see it a little bit, but it will not affect it.
Yeah, because it's happening in the strange part of the range of motion. Yeah. Now, another change that I saw is that in the first video, I was surprised that on your shoulder, which is pretty much the same kinematic strategy, is they were kind of going down in what I call an anhedral angle. And now you kind of moved it up to a dihedral. And I guess you've discovered that you wanted to go, otherwise your singularity was happening here. Now it's happening way up there. Okay.
So we have also for the other, I would say a pretty good solution. But still, if you're working in different environments and you have to do some precision movements, the other solution was not good enough.
Right.
If you're going somehow a little bit around, you're trying to solve the singularity.
Right. You're right around there at the singularity.
Yeah. And then it was sometimes you're getting stuck into stupid things where we thought, okay, why don't we just solve it?
Right.
I simply tilt it on the other side, and that's how.
But you still have that nice, that was what I really liked about the Gen 2, is it looked very natural the way the shoulders went down. You're able to maintain that aesthetic. So some interesting things with kinematics, the same kind of strategy down there at the ankles that we have up here, except in that case, they're parallel because you have no problems with the packaging. So from the standpoint of the kinematics, there's been some nice changes, but there's some other aspects to it that are non-kinematic that you probably like to talk about. And I think it's this area right in here.
This area. So what we have here is side one, it's the skin. So this is what we are showing there also. Yes, easier to show because normally they just get signals or not.
Yeah.
So here basically it's also when you touch it, it knows how hard you touch. It's actually just inside a paint. So what we do is basically we have, let's say, it's like printing on a surface. It's nothing else than a capacitive scheme.
Sure.
And through, let's say, how we solve it, like with the
It's like a cell phone screen.
yeah.
That's basically what it is.
Yeah, it's like with one of our technologies, basically the printing method, the way of how we do, and the like how we read it out, because it's like let's say pixels are like a very fine, and then you can actually simply, while touching the robot, feel before you touch, actually you feel already, and this is actually just there for the interaction part.
Okay, so it's here. Is it also in other areas? Everywhere.
We even now show it also for the let's say all the other industrial, let's say, cognitive robots. They inside the pane. I think I'd like to show you later there. Inside on the metal, inside the paint. So you will not see anything, but it's inside.
But it's there. So right now, it's going to know that I'm touching it there.
Yes.
Okay, that basically means the whole body is an e-stop if you want it to be. You could program it that way. As soon as, if I do something like that, that could be enough to say stop.
And mostly it's actually made to work closer to you. So it's not even just for safety. Safety is another topic. This is more about the interactive part. When I go like and fill up a bottle,
all right,
I'm not fearing to somehow hurt you, because I would touch you, I would not hurt you because I sense you.
Yeah.
So and this was the issue with them, because as soon as you're coming and working here, the camera might not see everything, and you're getting into, let's say, position where you simply push the road. The interacting part is very unnatural and very slow mostly. So because you're trying to not hurt a human. And in this case, you can actually go very close. So because it simply knows to go there, and as soon as you do. And the other thing we have inside is actually what you see up here.
Yeah.
It's actually the human detection center. It's like a radar technology combined with NADA. And what we did is basically just to sense we have it inside. So we know it's a human or not in front of you, and how many of them are there. And to have, let's say, this is actually important, because you don't want to be always, you want to be productive. You want to be like working with humans in the fastest speeds. But if you're coming, let's say, too close to it, it will simply go slower, going your side. Right. So this is like we do with robots.
I mean, that's what the cobots have been doing. So that's why you've already got that experience, because cobotic cells have been trying to set them up that way to slow down when we sense that there's humans around. So that's important for the human sensor overall for safety. Integrated in there. You also integrated some Lidar in here, I understand. Yep.
Yeah, here Lidar. It's a 3D Lidar inside. So it's basically there also for the navigation part, just to be precise when it's dark. So because that's the limitation of, let's say, the cameras is basically, we want to have dark factories, but how do you get them? Like
that's true.
The cameras are also affected by darkness, so it's like there is tools for solving that, but it's not as good as having a Lidar inside. That's why we just put it in for a time until, let's say, everything else catch up with being better. We have also right now a new design. It's like also in sensor fusion, where we simply have a camera with a Lidar in one. This a new thing, but it was not stable enough to get it in yet into the product. So that's one part. Cameras, we have 7 cameras inside.
All right.
So that is crazy. It's a lot of them.
And so you have what, like, not 7 here, but two there?
5.
Oh, 5. Okay, but overall there's 5. Overall there's 5. There's probably 2 there.
5 here and 2 in the back.
Okay.
1 here, 1 here, here, in the back. 2
okay.
So that's how.
So you surround view. Okay.
So you have, and it's 1, 2, 3, 4, 5. So you have.
Okay, that's the camera there, and that's the display right there, correct? Because I've been seeing the other one over there is able to display information right there in the faceplate. Yes. Yeah.
So and the cameras are there. Why do we put so many inside? It's basically to close the gap door. So we in the last version we had also on the side.
Mm-hmm.
No, so you work there, and you both mainly also you were not able to turn the head that way, that you can really cover that one. And at the same time also you want to be effective. So you don't want to just all the time look with your head, because this is ineffective in our opinion. It's the same with the industrial cognitive robots. It's good to have them in the head, to get a seam that to have a base where your reference are waiting for, but to get faster, it would be nice, like watching something already while doing something like in the other side also, so you have more let's say angles to watch on.
Mm-hmm. Yeah. Now, the other thing I wonder about safety Is it okay if I grab for anyone? And then look at that. Look at that. Back drivable. So if this, for some reason, it loses power and falls down on me, I can just move it out of the way. I mean, I'm not applying much force at all. It's very, very easy.
It's like, and it's under current.
Yeah.
It's actually super soft. So
Yeah,
still, like,
yeah.
this is now a pure the gearbox thing. In my opinion, not the very best.
But still, what it is this is what I call like analog safety, that the power goes out. For some reason, the software isn't working. It's completely back drivable.
That's also why we are not using, for example, a harmonic drive or something. Like, against harmonic drive, sorry.
Yeah.
I'm not using, let's say, strain wave gears. It's basically because the back-drivability is
not
like
there.
the most
It's right
important
there.
things
Yeah.
for robot. Also, when it falls, to not destroy yourself all the time.
Mhm.
And that's also where I see the most robots, they do use it, and I think it's super unrealistic.
Yes, so it could be a problem in back drivability for safety. You gotta remember the safety two ways. One, if the robot falls on me, that it doesn't hurt me. The other, if the robot just falls, it doesn't hurt itself.
Yeah.
So if it's able to absorb the energy, if it was stiff, it would come down, it's gonna break the elbow. But now it's gonna hit the elbow and everything's gonna move. Yes.
So it's also kind of freaky when it falls. Also,
Yeah.
a little like, but yes, it's, yeah. This is, I think, the core things about humanoids is that you cannot just use things which you use in industrial robotic space, because it's different. You're hitting all the time. Like, imagine by walking, you're hitting the ground all the time.
Right,
To
exactly.
use their, let's say, a straight wave here is pretty unrealistic, because they are not made for getting hit. So it's all about robustness. It's all about, let's say, also the weight and let's say the power they have, like, or how robust they are.
Okay, so final question that everyone always wants to know. The lights, they're blue right now. So blue, I guess, means it's neutral. Okay. When it's red, what does that mean?
Error.
Okay, and what other colors do you have?
Green.
Green. Green means it's operating. Operating. Any other?
Yes.
Is there one for like I need to charge?
No, it's this one is actually on the back. These are actually these colors here.
Uh-huh.
They're not like this.
Ah,
So they're exchangeable.
and there's two of them.
There's two of them, and
Yes.
you know why? Because, and that's also why we say in upgrade 24/7, because you can exchange one to the other like all the time.
Mhm.
This gives the, let's say, the like, because that was one of the big things need to be solved for humanoid robotics is energy.
Yeah.
And especially here, you see a 180 centimeter, so 80 kilogram old
You
weight.
can see it's
I'm 183, so
it's not the same. Yeah.
so, and it's yeah, we try to do it exact the at the part here. I said, okay, one day I will look like that again. So
Exactly.
but yeah, that's actually very constructive. It's the size, and then at the same time, like the weight itself. So you use a lot of the power just to hold yourself, and that's the, I'd say, still the part which needs to be solved. And how do we solve it? Well, we simply said there has to be a battery exchanging all the time. It's much easier than just charging it somewhere.
Sure.
So what we do is basically we have one that you can plug yourself in. The other is basically, because you go into work somewhere, you can plug yourself in and work. And the other is basically you can simply exchange. So what we are showing you in our labs, you mainly use a NEURA to exchange them.
Oh, sure.
Because it's nothing else, and you're just clicking it, and to take them out, take the other in.
Okay, so for anyone that doesn't know, there's a huge ecosystem around here of different bots that aren't just humanoids. So they would be able to interact within that ecosystem.
Yeah.
So again, thank you for your time. I know it's very precious. You have a pretty busy schedule here, and thank you for the tour. And I'm looking forward to coming down to Stuttgart.
Yes, also looking to have you there.
Yeah. Okay.
Thanks so much.
Thank you, David. Yeah.
Thank you.
Yep.